Right, in this video we're going to continue with our examples on these 4 planes. In the previous video we just covered part A. So in this video we're going to go to part B, C, and D and E, depending on the time. So in example number B, we want to determine whether these 2 points, so there is P1 and there is P2, whether they lie on the plane pi 1. So the best way to do this is via the or the quickest way is via the scalar form of the equation for pi 1. So let's just scroll up to find that scalar equation for pi 1. So there is pi 1, and there is the scalar equation. So we are just going to, it's just a simple simple job of direct substitution, really. So there is the scalar equation for pi 1. Now the first point, maybe let me just bring both of them down. Yeah, well, both of them. So the first point is 9 minus 1, 3. So if that satisfies the equation, then the point is on the line. So if we substitute, so for P1, I'm going to substitute 9 plus 3 times negative 1 plus 7 times 3. So that's the left hand side. So it's going to be 9 minus 3 plus 21. 9 plus 21 is 30, minus 3 is 27, which is the right hand side. So we can conclude that P1 lies on the plane P1. And then we do the same thing for P2. So it's minus 3, 4, 7. So it's going to be minus 3, 4 plus 3 times 4, and then plus 7 times 7, plus 7 times 7. Going to be minus 3 plus 12 plus 49. Doesn't look like it's going to be 27. So let's see, minus 3 plus 12 plus 49, minus 3 plus 12 plus 49 is 58, which is not equal to 27. So we can conclude P2 is not on plane 1. So this one is not on plane number 1. So that concludes part B. Part C, find 2 other points on plane number 2. Okay, so I'm just going to bring down the equations for plane number 2. The ones that are going to be useful for this will be the parametric form of the equation, which is this one here, and well, also the scalar we can use either of the two, but for generating points on a plane, it's the same thing for straight lines. The parametric form of the equation is going to be the easiest to do that. But we're going to use both of them. We've actually somewhere else already generated points using the scalar equation, but we're going to use both forms and show you how this works out. So this is the parametric form. Yeah, so let's generate points. So they say two other points. So there is one point that I believe was given for plane number 2 as part of the question. So there is plane number 2. Yeah, so actually there's 3 points that were given. So if the question says generate 2 other points, that means besides these ones that were given. Okay, so I'm just going to bring them down again so that as we generate points, if we are getting one which is the same as the ones that were given, then we're going to keep generating. So I'm just going to put those ones here. So these ones were given. All right. So all you do when you're using the parametric form of the equation to generate points is you just arbitrarily choose values of the parameters. For instance, if lambda is equal to mu is equal to 0, I think we'll find that we'll get one of these points. Okay, because x is going to be 2, y is going to be -1, and z is going to be 1, which gives us this point here. Okay, so what I'm going to do now is I'm going to go with well, let's say lambda is still 0, but mu is 1. Okay, so if mu is 1, lambda is 0, then this is going to be 1, x, y is going to be 1 as well, z is going to be 2. Okay, so that's 1, 1, 2, and it's not one of these points here. Can stay with lambda equal to 0, go to mu equal to 2. This is very there's an infinite number of points on this plane, so the way we generate them is very arbitrary. So if mu is 1, still lambda is 0. Mu is 2 now, so x is now going to be 2 minus 2 is going to be 0. Okay, this is going to be -1 plus 4, which is 3. So well, thankfully it's not that point. Then this is going to be 1 plus 2, which is 3. So this is giving us 0. Just write it down. 0 is x, y is 4 minus 1, and z is 1 plus 2. So that is also going to be on the plane, and we've got 2. I'm just going to generate another one just out of interest. If we swap these around, suppose lambda is 1, mu is 0. Okay, so that's going to give us another point. So in this case, x is going to be 1, because we have 2 minus 1. Y is going to be 0, because was simply just you know, so these ones are all zeros, so 1 0, and this one is going to be -2, but that's that point there we already have, so this one is not going to work. We could go mu is -1, sorry, lambda is -1, mu equals to 0. So again, this third column, if you like, it's just zeros, but this is -1 now. So that's going to be 3, it's going to be -2, and that's going to be 5. I don't think we have that point. So that's 3, -2, and 5. So we've now generated 3 points. So we could do the same thing with the scalar equation, but it's going to be we're going to have to solve equations at each point. So the first thing I'm going to do now is I'm going to bring down the scalar equation and then show that all the points we've generated must satisfy the scalar equation. Okay, so all the points we generated using the parametric form. So let's start with this one. So we've got x is 1, y is 1, z is 2. So it's going to be 7 plus 4, which is 13, minus 2. 13 minus 2 is 11. So that's giving us a bit of a problem. No, wait. 7 plus 4 is actually 11. Then minus 2 is 9. So that's okay. And then this time x is 0. Both y and z are 3. So it's going to be 0, going to be 12 minus 3, which is 9. And then you can do the same thing with that. Now, if you're generating the points using the scalar equation, it's usually easier to choose 2 of these to be zeros and then solve for the other one. So for instance, if both x and y are 0, so we've got 0 0, then z is going to be -9. Then maybe if y and z are 0, so y and z about 0, so 7x is going to be 9, so x is going to be 9/7. So typically using this, you find that you get values or points with fractional values of the coordinates. But yeah, so basically that is that. We have got those 2 points. So the bottom line, it is more efficient to use the parametric form of the equation to generate points. Part D, find 2 vectors parallel to pi 3. So I'm just going to go up to, there is pi 3. So they told us it goes through this point, and it is perpendicular to this straight line. So the way I am going to do this, so the easiest way to find vectors that are parallel to a plane is to find vectors that are actually inside the plane, because those vectors are going to be in the same direction as the plane, or with the same direction vectors. So just going to go to the parametric form of the equation of plane number 3, generate 3 points. Then from those 3 points we can form two equations. So there is plane number 3. There are the parametric equations. Okay, we already have 1 point on this plane, so we just need to generate 2 other points. If we've got 3 points, then we can form 2 or actually 3 vectors, because we're just going to change the sides of the triangle that we're going to have into vectors. So so if you imagine this is our plane, so imagine this is our plane. So when both mu and lambda are 0, this is giving us the point 1, minus 3, minus 2. Let's call that one A. So A is 1, minus 3, minus 2. We need 2 other points. When lambda is 1 and mu is 0, suppose we call that one B. So lambda is 1, mu is 0. So x is going to be -1, y is going to be -5, z is still going to be -2. So that's B. C, then that's going to be good enough. We can get actually 3 equations from, 3 vectors from this. Suppose we go for mu is equals to, lambda equals to 0, mu equals to 1. So x is going to be 0, 1 minus 1. Y is going to be -3 minus 3. And z is going to be -2 minus 2. So we have got 3 points on the plane. So now AB is a vector. If it's a vector in the plane, so it's going to be parallel to the plane. Okay, so that's going to be -1, -1, -2, -5, minus -3 is -2, -2 minus -2, which is 0. So that vector is in the plane, is going to be parallel to the plane. Then we could do AC. So it's going to be this vector here, which is in the plane. 0 minus 1 give us -1, -6 minus -3, then -4 minus -2 is -2. So that is going to be the second vector. If we needed another vector, we could do BC, of course, but we only need 2 vectors. So in terms of answering that question, this is already good enough. Let's see what time. Okay, it's already 20 minutes. Find the intercepts of the third plane with the coordinate axis. So for this, we need the scalar equation of pi3. When did we have pi3? That's the previous question. Do we have the scalar equation for pi3? Let me just scroll up. It's pi4. There is pi3. So that is the scalar equation for pi3. the scalar equation for pi 3. So just going to paste it here, and then that's what we're going to use to answer this question. So there's a scalar equation for pi 3. Now the question is asking for the intercepts of this plane with the coordinate actually coordinate planes. The question should be saying, oh well, the question is saying coordinate axes. That's fine as well. I think maybe in the video, and then we'll do this in the next video, because this is already 20 minutes. We don't want the videos to be too long. We will break this into 2 questions. So we will first do the intercepts of pi 3 with the coordinate. We'll do part 1, coordinate axis. Part 2, we'll do the coordinate planes, because in 3D space you got coordinate axes and coordinate planes. The axes are lines, and then the coordinate planes are planes. Okay, so we'll do that in the next video.